either of these problems, the first thing we have to do is get it equal to 0 so that we can apply our quadratic formula. So for number 1 here, we have to subtract 5x from both sides. And then we're also going to have to add 11 to get rid of the negative 11. So we have 2x squared. Negative 7x minus 5x is negative 12x. And 3 plus 11 is 14, equals 0. And if we recall, a is the coefficient of x squared, b is the coefficient of x, and c is our constant. So the quadratic formula is opposite b. Well, b is negative 12, so the opposite of that is positive 12, plus or minus the square root of b squared, so b is negative 12, so that's negative 12 squared, minus 4, yeah? So it's b squared minus 4 times a, which is 2, times c, which is 14, all over 2 times a, so 2 times 2. So now we'll combine what we can here. Inside the square root, negative 12 squared is 144, minus 4 times 2 times 14 is 112, all over 4. (144) minus 112 is 32, over 4. So now I have to try to reduce that 32. And what I'm going to do is I'm going to split that 32 into 16 times 2, because I can do the square root of 16. So that means we've got 12 plus or minus. The square root of 16 is 4. And then, of course, the square root of 2 is still under that. Oops, and this is over 4. And all of those numbers can be reduced or divided by 4. So that gives us 3 plus or minus the square root of 2. How many of you had that answer for the first one? You tried to do the completing the square?
No, I took the 2x squared minus 12x plus 14. I divided by 2 and then I just factored it.
Okay. If you divide by 2, does that factor?
Yeah.
It does, doesn't it? Minus 7 and plus 1.
Yeah.
So what did I do wrong that didn't come out? Oh, no, it does not come out. That does not factor. It would have to be a negative 7 down here for that to factor. So it does not quite factor out. Because you have to have a negative 7 and positive 1, and that would be a negative 7 that would multiply out to. Let's try number, did you get done with number 2, or do you guys need another minute to try 2? Another minute? Okay, we'll go one more minute, and then we'll go over it. So I realize that might not be enough time to quite finish up yet, but let's go ahead and look at this, see how you're doing. Same thing here, we have to get this equal to 0 on one side or the other. 5x squared is the larger of the two, so we're going to move everything over to this left side. So we're going to get rid of everything on the right side. So we're going to subtract x squared from both sides. We're going to add 5x to both sides and subtract 4 from both sides. So we've got 0 on the right side, everything there cancels out. 5x squared minus x squared is 4x squared. 3x plus 5x is 8x. And negative 9 minus 4 is a negative 13. So again, we have a equals 4, b equals 8, and c equals a negative 13. So opposite of b, since b is 8, that'll be a negative 8. Plus or minus the square root of b squared is going to be 8 squared minus 4 times a is 4 times b is a negative 13 all over 2a. So it'll be 2 times 4. So it's negative 8 plus or minus 8 squared is 64. Now, I'm going to treat this as negative 4 because there's a negative 13 here, so that's going to multiply to make a positive. 4 times 13 is positive 208. Of course, on bottom, 2 times 4 is 8. $64 and 208 make 272 over 8. Let's try to split 272 up a little bit here. Let's see, 272 can be split, if I factor that, let's just go ahead and do a factor tree here. I'm going to split it up into 8 times what? I know it's divisible by 8. 8 times 34. 8 splits into 2 times 4. The 2 is prime. 4 splits into 2 times 2. 34 splits into 2 times 17. So what I'm going to break that 272 into is, looks like 16 times 17. Just double check that. That is 272. So the 16, the square root of 16 is 4. So this is negative 8 plus or minus 4 times the square root of 17 over 8. And once again, we see that all of the numbers here can be reduced by the same thing. They can all be divided by 4. So it's negative 2 plus or minus the square root of 17 all over 2. Any questions? Now we left these in this form with the radical form in there as a radical number. We could have got a decimal equivalent or approximate decimal equivalent, but in these problems like this without a context, it's okay just to leave them as that radical form. But there might be an application where we want to do that decimal approximation, like this. Find each length to the nearest 1/100th of an inch. Where I tell you that my lengths are x plus 70, and x plus 90. Well, we know a squared plus b squared equals c squared. Here, a, we're going to label this a, b, and c. C is always the hypotenuse. So a is just x, so that'll be x squared. B is x plus 70, so that's x plus 70 squared. And c is x plus 90, so that's x plus 90 squared. So this is still going to be just x squared. This is going to be x squared plus 140x plus 4,900. This will be x squared plus 180x plus 8,100. So I'm going to subtract an x squared from each side. Of course, we know this is 2x squared, so we're going to subtract an x squared from that. We're going to subtract a 180x from each side. And we're going to subtract 8,100 from both sides. So our right side reduces down to 0. Everything cancels out. On the left side, we've got x squared, negative 40x, and a negative 3,200, I believe. So for a quadratic formula, opposite b, well, b is 40, so it's, or negative 40, so opposite b is positive 40, plus or minus the square root of b squared is negative 40 squared minus 4 times a is just 1 times c is negative 3200 all over 4, or 2a. Well, a is just 1 again. So this is 40 plus or minus, inside the radical here, negative 40 squared is 1600 plus negative 4 times 1 times negative 3200 is 12,800 all over 2. We're going to combine here. 1600 plus 12,800 is 14,400 all over 2. When we go to reduce 14,400, we actually find that you can take the square root of 14,400 and get 120. So that's 40 plus or minus 120 over 2. So this becomes two problems now. The first one is, and pick which one you want to do, whether it's plus 40 plus 120 over 2, which is 160 over 2, or 80. The other potential solution is 40 minus 120 over 2, which is negative 80 over 2, which would be negative 40. Well, because this is a problem that deals with lengths of the sides of triangles, you can't have a negative length. So that negative 40 is not a legitimate answer. So 80 is the answer we're looking for. X is 80. 80 plus 70 gives us 150 here. And 80 plus 90 gives us 170 there. Any questions on that one? Okay. So where we left off on Wednesday, we were talking about equations that are in what's called quadratic form. And what quadratic form was, where we had three terms. That last term was a constant, and the other two terms, the powers were related. So the second term has a power. The first term, the power is 2 times that power. So it could be 2x to the fourth minus 7x squared plus 18 equals 0. Part of the quadratic form, by the way, is it does have to be set equal to 0. And we see here that it's not x and x squared, but it's x squared and x to the fourth. And because that power of 4 is double the power of 2, this is still in quadratic form. In fact, you could try to factor this if you wanted to. Now, this one is not going to factor, but we can apply the quadratic formula by saying we're going to let u equal x squared. And by making that change, this becomes 2u squared minus 7u plus 18 equals 0. Now this is a quadratic equation, and we can do a equals 2, b equals negative 7, and c equals 18. We can plug it into the formula. Opposite b, well, b is negative 7. So opposite of negative 7 is positive 7. Plus or minus the square root of negative 7 squared minus 4 times 2 times 18. All over 2a would be 2 times 2. Negative 7 squared is going to give us 49. 4 times 2 times 18 is going to give us 144 over 4. We do the 49 minus 144 is going to give us a negative 95. Well, that being a negative number, we're taking the square root. That's going to give us an I in our answer. So what we're going to find here, the only thing we can do to reduce that, by the way, 95 is 5 times 19, both of which are prime, and neither of them is a perfect square. So this breaks into 7 plus or minus I times the square root of 95 over 4. So U equals those two possibilities. So 7 plus I times the square root of 95 over 4. 7 minus I times the square root of 95 over 4 are the two answers for U. But remember, U is equal to x squared. So to solve for x, we have to set x squared equal to each of these. To solve that for x, we have to square root them. So x is equal to the square root, the positive and negative square root of 7 plus I root 95 over 4. Now we could actually take the square root of 4 there. So x is equal to the positive or negative square root of 7 plus I root 95 all over 2. And then the same over here. X equals the positive or negative square root of 7 minus I root 95. And we can take the square root of 4 to get 2. So notice there are 4 answers there. Each of these is 2 answers. You got the positive and the negative root. Let's look at some examples that work out maybe a little bit neater. Let's try x minus 3 times the square root of x minus 10 equals 0. Now here, I'm going to let U equal the square root of x. So that means x is actually U squared, because the square root of x squared gives us x. Minus 3 times U minus 10 equals 0. Now I'm going to pause here. Any questions on how we came up with that? I just changed it over so that instead of the square root of x, we're dealing with U and U squared instead of the square root of x and x. Now, we could use the quadratic formula, but if you look at this one closely, it's actually factorable. Minus 5 and plus 2, very good. So then we can solve. Either U minus 5 has to equal 0, or U plus 2 has to equal 0. From there, we'll add 5 to both sides. Either U equals 5, or this one we subtract 2, U equals negative 2. But remember, U equals the square root of x. So I have to put in U equals 5, means the square root of x equals 5. U equals negative 2 means the square root of x equals negative 2. To solve for x, we have to square both sides. So the square root of x squared is just x. 5 squared is 25. We do the same here. We square both sides. The square root of x squared is just x. Negative 2 squared is 4. Now we should test those answers to make sure they work. So back up here, 25 minus 3 times the square root of 25 would be 5, minus 10. Does that equal 0? Yeah, 25 minus 15 minus 10 does equal 0. So 25 works. Let's try 4. This 4 minus 3 times the square root of 4 would be 2. Minus 10, does that equal 0? It does not. It's because this was a negative 2. When we squared it, we lost the negative. That doesn't work. So the only solution that works out of these possibilities is that one, the x equals 25. We might have something even more complex, like x to the power of, well, let's do 4 thirds plus 7 times x to the power of 2 thirds plus 12 equals 0. When we look at this one, actually I'm going to make it easier. I'm going to make that minus 7 here. So we end up with some positive numbers. When we look at this one, you might not see right away that this is in quadratic form. But if you take 2 thirds times 2, you do get 4 thirds. So the power is double in that first term compared to the second term. So we're going to let u equal x to the power of 2 thirds. So u squared is going to be x to the power of 4 thirds. So we can make those substitutions. So u squared minus 7u plus 12 equals 0. Again, you're more than welcome to use quadratic formula here. This is factorable, which is a little bit easier than going through the whole formula. What do we get when we factor that? U minus 4 or U minus 3? You got it. So that's telling us U minus 4 equals 0 or U minus 3 equals 0. I can add 4 here to get U equals 4. Or here I can add 3 to get U equals 3. Now remember, we have to solve for x. U equals x to the power of 2 thirds. So x to the 2 thirds equals 4. To solve that, I have to raise it to the power of 3 over 2. 2 thirds times 3 over 2 is going to be 1. So that'll be x to the 1. Any questions on where I got the 3 over 2? It's just the reciprocal of 2 thirds so that when you multiply them together, you get 1. So these cancel out. That's just x. 4 to the power of 3 over 2, that's saying the square root of 4 to the third power. Remember, the denominator is the index of our root. The numerator is a power. Well, the square root of 4 is 2, so that's 2 to the third power, or just 8. Now, there is another possibility. The square root of 4 could be a negative 2. Negative 2 to the third power could be a negative 8. We need to explore that as a possible solution here. The other one we had was the third, u equals 3. So let's look at u equals 3 and see what that gives us. X to the 2 thirds equals 3. Take that to the power of 3 over 2. X equals the square root of 3 to the third power. Or I could write it as x equals the square root of 3 to the third power. So x equals the square root of 27. And so, of course, there's a positive and negative to the square root of 27. All of these solutions now need to be tried back in the original problem. Our original problem was x to the 4/3 minus 7x to the 2/3 plus 12 equals 0. Just making sure I got that right. Yep. Let's try positive 8. So 8 to the 4/3 minus 7 times 8 to the 2/3 plus 12 equals 0. 8 to the 4/3. The third root of 8 is 2 to the power of 4 is 16. Minus 7 times 8 to the 2/3. Third root of 8 is still 2. Squared is 4. So this is 16 minus 28 plus 12, which does equal 0. So positive 8 works. Positive 8 we know is a solution. Let's try negative 8. So negative 8 to the 4/3 times 7 to times negative 8 to the 2/3 plus 12 equals 0. Well, negative 8 to the 4/3. The third root of negative 8 is negative 2 to the power of 4 is 16. Minus 7 times negative 8 to the 2/3. The third root of negative 8 is negative 2. Squared is positive 4. Well, that's exactly the same as what we had up here, so that's going to check out as well. So negative 8 is also a proven solution. Now we need to do the square root of 27. I'm going to write it as 27 to the power of 1/2. So 27 to the power of 1/2 to the 4/3 minus 7 times 27 to the power of 1/2 to the 2/3 plus 12 equals 0. Well, 27 to the power of 1/2 to the 4/3. 1/2 times 4/3 is 2/3. (27 to the power of 2/3). Well, the third root of 27 is 3. Squared is 9. Would it matter if it was a negative 27? No, the third root of negative 27 would be negative 3. Squared would also be 9. So then minus 7 times 27 to the 1/2 to the 2/3. 1/2 times 2/3 is just 1/3. 27 to the 1/3 is 3. Negative 7 times 3 is negative 21. Then, of course, we got plus 12. That adds up to 0. So the square root of, the positive square root of 27 works. If it were negative, as we said earlier, we still get a positive 9 here, but this one, that's a negative 27, would be a negative 3. The third root of negative 3 or negative 27 would be negative 3. Negative 7 times negative 3 would be a positive 21. That would not work. So the negative square root of 27 does not work. So our solutions here are 8, negative 8, and the square root of 27. What do you think? Loads of fun? I'm going to have you guys try one here. Trying to think of one that's going to work out well for you. Can I really be that mean? Yeah, why not? X to the 14 thirds minus 9x to the 7 thirds plus 20 equals 0. I'm going to give you a couple minutes, see what you come up with. This one might have been a little bit unfair, but let's take a look at it. What are we going to set u equal to? X to the power of 7 thirds. Good. So u squared is x to the power of 14 thirds. So this is u squared minus 9u plus 20 equals 0. And of course, that factors to be what? U minus 5 and u minus 4. We solve those. I'm going to skip some steps here. U equals 5 or u equals 4. Now we substitute back in x to the 7 thirds. So x to the 7 thirds equals 5. To solve this, we have to do to the power of 3/7. So we get x equals 5 to the power of 3/7 is the 7th root of 5 to the 3rd. That's the 7th root of 125. Remember, when it's an odd root, there isn't a positive or a negative. It's just that. If it were an even root, it'd be plus or minus. For the u equals 4, well, x to the 7 thirds equals 4. We have to raise that to the power of 3/7 again. So x to the 7 thirds to the power of 3/7 is just x. This is the 7th root of 4 to the 3rd. 4 to the 3rd power is just 64. So x is the 7th root of 125 or the 7th root of 64. What do you think? Not so bad? Looking for that sharp stick? Okay, so our next step. We might run into something like this. X minus 3 squared plus 3 times x minus 3. Actually, let's make this a little bit different. Let's do 2 times x minus 3 minus 35 equals 0. What are we going to let u equal here? What do you think? X minus 3, very good. So this becomes u squared minus 2u minus 35 equals 0. Is that factorable? What was that? That should be a plus 2, thank you. And factors to u plus 7 and u minus 5, right? So again, I'm going to skip a step here. You guys know how to solve this equation. So if you solved u plus 7 equals 0, you'd get u equals negative 7. U minus 5 equals 0 give you u equals 5. I'm just shortening that up. Well, now we have to solve for x. We're going to put x minus 3 in for u. So x minus 3 equals negative 7. What do we have to do to solve for x? Add 3. Good. So x equals negative 4. Well, x minus 3 equals 5 is the other option. We're going to add 3 to get x equals 8. So negative 4 and 8 are our possible solutions. If we try those in there, we should go back and test them. Both of them do work. So the biggest thing here is finding the correct choice for u. If you get a good choice for u, you substitute it in and it works well like that. This method, solving quadratic formed equations, turning them into quadratic so that we can either factor them or use the quadratic formula, is a very powerful tool in a lot of problem solving applications. For example, we might run into something like this. An electrician and apprentice can complete a job in 18 hours. Alone, the electrician, I'm just going to use a little shorthand here, can complete the job 6 hours faster. I better write it out. The electrician can complete the job 6 hours faster than the apprentice. Alone. Find the time for each to complete the job. So we have a job, one job. The amount that each gets done in an hour would look like this. If we let X equal the hours for the apprentice to finish. That means X minus 6 would equal the electrician. The amount of the job that the apprentice would get done in 1 hour would be 1 over X. The amount of the job that the electrician would get done in an hour is 1 over X minus 6. If we add those together, we get the amount that the two of them would get done in an hour. Since we know it takes 18 hours, the two of them together, then together they would get 1/18 of it done in a single hour. And we have to solve this equation. Well, to solve this equation, we go back to what we were doing a couple weeks ago. We have to multiply by a least common denominator, least common multiple. In this case, that's going to be x squared minus 6x. When I distribute here, x squared minus 6x, remember, is x times x minus 6. So for this one, The x's are going to cancel out, and we have just x minus 6. When we multiply by this next term, the 1 over x minus 6, the x minus 6's are going to cancel out and leave us with just x. And over here, that's going to be x squared minus 6x over 18. Trying to solve this now, I'm going to multiply both sides of the equation by 18 to get rid of this 18. This is 18x minus 18 times 6 is 108 plus 18x equals x squared minus 6x. Now I could have combined these two before I multiplied by the 18, but it doesn't matter. 18x and 18x is 36x. Minus 108 equals x squared minus 6x. Now the x squared over here is positive, so I'm going to leave it over there. I'm going to subtract 36x from both sides. I'm going to add 108 to both sides. So I have 0 equals x squared minus 42x plus 108. This is now a quadratic equation. We could try to factor this, I suppose. Oh, what do we have? We know 108 is divisible by 2. That'd be 2 and 54. 6 and 18 isn't going to do it. 3 and 36 won't do it. Let's give up on factoring and let's try to use our quadratic formula. So A equals 1, B equals negative 42, and C equals 108. So opposite B is going to be 42, plus or minus the square root of negative 42 squared minus 4 times 1 times 108 over 2 times 1. Negative 42 squared is 1764. Minus 4 times 1 times 108 is 432 over 2. 1764 minus 432 is 1332. Over 2. Can we break down 1332 at all? Let's try it. If I factor it, it's even, so I know it can be divided by 2. Giving us, try that again, is 666. We can take out another 2, which is 333. Take out a 3, which gives us 111, and that's it. But we can take out a 2. So I'm going to split that into the square root of 4 times 333. And of course, the square root of 4 is 2, so that's 2 times the square root of 333 over 2. And now we can divide out that 2 from every term in that radical expression. (42 divided by 2 is 21, plus or minus. The 2 divided by 2 cancels out. That's the square root of 333. And the 2 divided by 2 cancels out to be a 1. So this is just 21 plus or minus the square root of 333. Now here's a case where we want numbers for this. So 21 minus the square root of 333 would be 2.75. 21 plus the square root of 333 would be 39.25. The 2.75 doesn't make sense because the two of them together take 18 hours. One of them alone, the apprentice alone, can't do it faster than the two of them together. So it's the 39.25 is the answer that makes the most sense. So we go up and answer the question. The apprentice takes 39.25 hours alone. The electrician minus 6 would be 33.25 hours alone. That one's a mouthful. Any questions? The tough part of these is coming up with those equations. Like I had that one, the 1 over x plus 1 over x minus 6 has to equal 1/18. So let's look at least one more example here to see how it works out. We're going to do, I'll say a business is going to purchase items. They're going to purchase X items, put it that way. They sell each at $50 over cost. When all but 5 are sold, they've recovered the cost. So in other words, there's 5 left, but they've already made back all the money they spent on buying them in the first place. So the last 5 are going to be their profit. How many units were purchased? If the total cost was $18,000. So let's look at this. Let's look at the unit cost here. If X is the number of units sold or units purchased, it's right there. X minus 5. Let's do it the other way around. Let's do X plus 5 is the units purchased, and X is the number of units sold. That'll make it a little easier. The amount that they paid per unit is 18,000 divided by X. Actually, that's the amount that they charged per unit, is 18,000 divided by X. So when they sold them, they sold X of them, and they recovered their cost. So 18,000 divided by X is the amount they charged per unit. That has to equal to the total cost, what they paid per unit. What they paid per unit is 18,000 divided by X plus 5, plus $50. They had added $50 to each. So now to solve this equation, we're going to multiply this whole thing by a common denominator, which is X times x plus 5, otherwise known as, if we prefer, x squared plus 5x. So when we do the first piece here, the x cancels out. That's 18,000 times x plus 5 equals, the second piece here is the x plus 5 that cancels out. That's 18,000 times x plus 50. Oops, not plus 50, plus 50 times x squared plus 5x. So this is 18,000x plus 18,000 times 5 is 900,000. Oops, sorry, not 990,000. Equals 18,000x plus 50x squared plus 250x. Now, technically, I should combine these two next. But instead of doing that, I see that I have an 18,000x on each side. So I'm just going to subtract that from each side. So that leaves me with 90,000 equals 50x squared plus 250x. So I still have to get this equal to 0, so I'm going to subtract 90,000 from both sides. So 0 equals 50x squared plus 250x minus 90,000. The big question is, could this be factored? That's very possible that it could be. You'd have to come up with something that equals 250x. I believe 90,000 can be broken down into 450 times 200. So x plus 450 and x minus 200 would be our factors. X plus 450 equals 0. Subtracting the 450 gives us x equals negative 450. That one we're going to cross off right away. Couldn't buy negative 450 units. X minus 200 equals 0. Adding 200 gives us x equals 200. So that is our answer there. 200 units is x, which is the number of units sold, which means they must have purchased 205. What do you think? Writing is going to take some practice to write these equations. This problem-solving part here is going to, put it this way, there will be some problem-solving stuff on the homework and a couple on the quiz, but on a test I'll try to keep it to a very simple form of a problem-solving question on that. But it's definitely something on the homework to pay very close attention to. Don't be afraid to use your hints, help me solve this and stuff like that in the homework, just so you can get used to the patterns that you have to go through to solve those types of problems. A little bit of review for a second to help set us up for tomorrow, foreshadow for tomorrow. Linear inequalities. We had things like this. 3x minus 7 is less than or equal to 20. We solved that by adding 7. To get 3x is less than or equal to 27. And then dividing by 3 to get x is less than or equal to 9. We had 3 ways of expressing this answer. Set notation looked like this. The solution was all values of x such that x was less than or equal to 9. Interval notation. Went from negative infinity up to 9. Note the square bracket on the 9 indicates that it could equal 9. That's the or equal to from up here. And the third way was to simply put it on a number line. Here's 9 on our number line. We could either express it, since it's or equal to, we could have used a closed dot, less than or equal to points that way, or we could have used, to kind of mirror the interval notation, could have used a square bracket at the 9. Either one of those indicate that the 9 is included in that answer. Well, today we're going to look at, or starting tomorrow I should say, but to foreshadow to tomorrow, we're going to look at things like x squared minus 3x minus 15 is greater than 0. Now note, it is solved for 0. It is factorable. It factors into x minus 5 and x plus, oops, I screwed something up there. This should have been a 2x here, sorry. X squared minus 2x minus 15. So that factors into x minus 5 and x plus 2. Not plus 2, plus what? Plus 3, thank you. Now, unfortunately, we can't just go ahead and break this into 2 pieces now. We need this to be, the product to be greater than 0. To be greater than 0, if it's positive, that means both factors are positive. So we need x minus 5 to be greater than 0 and x plus 3 to be greater than 0. Or they have to both be negative. So if we look at a number line here, we have a couple of breaks here. If I solve this one to be equal to 0, that would be x equals 5, right? If I solve this one to be equal to 0, that would be x equals negative 3. So these are our points of interest. It divides our graph, those 2 solutions to the quadratic equality, if we assume that this was equals, provide our boundaries and divide that number line into 3 regions. So let's look at those 3 regions. Over here, This, if x is less than negative 3, this is definitely negative, isn't it? How about this one? That's also negative. Both of them are negative over there. So if they're both negative, that is part of the solution. In here, in this section, I'm going to switch colors here. In this section, x minus 5 is still negative. X plus 3, however, is not. It is positive. So that is not part of the solution. Up here, x minus 5 is positive. X plus 3 is also positive. That is part of the solution. Since it is strictly greater than and not greater than or equal to, we have either open dot or rounded brackets, open-ended, either way. So our solution looks like this. If we were going to put that in interval notation, it'd be negative infinity to negative 3 unioned with 5 to positive infinity. Does that make sense? So we have to look at the possibilities. We have to take it, we can't just solve each piece separately. We have to look at when each piece is positive and negative. Similar to that, we might have rational inequalities. We might have something like 3x minus 2 over x plus 1 is less than 0. Now again, what this is saying is to be less than 0, this has to be negative, right? So in order to be negative, one has to, either the first one's positive and the second one's negative, or the first one's negative and the second one's positive. Can't be both. So this is going to give us some boundaries on our graph as well. We solve each piece. We set 3x minus 2 equal to 0. If I solve that, that would give us that x equals 2/3. That's one of our boundaries. The bottom piece would give us x plus 1 equals 0, which would give us our second boundary. Of x equals negative 1. So if we look at a number line, here's 0, here's negative 1, here's positive 2/3. So we'll treat those as our boundaries here. If we're over here, x minus 1 is negative, isn't it? Or x plus 1 would be negative. How about 3x minus 2? Would that be negative or positive? 3x minus 2, if I have something smaller, if I have negative 1 in there, that would be negative, right? So both of them would be negative here, which would make the quotient dividing the two positive. That's not part of our answer, because a negative divided by a negative would be a positive. We want it to be less than 0. We want it to be negative. In the middle here, x plus 1 would be positive. 3x minus 2, however, if you put 0 in there, that's negative. That works. That's a negative divided by a positive. That gives us a negative. That is part of the solution there. Up here, well, if we're bigger than 2/3, x plus 2/3 is still definitely positive. 3x minus 2 is also positive. They're both positive up there. That's not part of our solution. So our solution is this piece in the middle here, which will be on a number line. Goes from -1 to positive 2/3. And again, it was strictly less than, so it's open dots, or either it'd be look like this, or I'd use the curved brackets. Or if you did it in interval notation, it's -1 to 2/3. We are going to look at those more tomorrow. But the key here is being able to pick them apart case by case. We have two factors. It doesn't matter whether we have, like up here, where the factors are multiplied together, or down here, where the two factors are divided. We know things are positive when both of them are positive or both negative. We know things are negative when there's one of each. And then we have to go case by case. We find the boundary for each and analyze it. Again, we're going to do more of that tomorrow. Today's material was that quadratic form, and homework 14A is going to deal with that. Make sure you have done for tonight homework 13, A, B, and C, along with quiz 13 is due tonight. Any questions? Okay, great. Only 2 weeks of lecture left, so we're almost there. You guys have a great night.